Today we are going to see a case study on Bezier curves in the course Computer Graphics and Visualization. So first let me give an introduction about the Bezier curve. A Bezier curve is a parametric curve which is used in computer graphics and related fields. A set of discrete control points defines a smooth continuous curve by means of a formula. Usually the curve is intended to be approximate a real world shape that otherwise has no mathematical representation or whose representation is unknown or too complicated. The Bezier curve is named after French engineer Pierre Bezier, who used it in the designing curves for the bodywork of Renault cars. So other uses include the design of computer fonts and animation. So Bezier curves can be combined to form a Bezier spline or generalized to higher dimension to form Bezier surfaces. So the Bezier triangle is a special case of the latter. So let's move on to the discussion.
So hi team, today we are going to discuss about a project where we have to do a project on computer graphics. So we are here to discuss about that. So in this project in the sense we have to work on a project which is more interactive and which applies to the real world. So let's discuss about that project.
I was reading about Bezier curves last night.
They are the smooth curves you see in digital drawings, animations and even in design car bodies.
We have come across the illustrator. We move little handles on anchor points to curve, change shape it, innovative but math behind it too.
I use the Bezier curve in the blend all the time. So they make it easy to animate the path like a camera or object moving smoothly along the road.
They're not just using graphics. I read that Pierre Bezier, an engineer in Renault, he used it to design it back in the 1960s, an historical angle that could make a assumption easy.
Yeah, that sounds perfect. Visual, interactive, historical, and mathematical. Let's do it.
Yes, it seems good when we are going to work with Bezier curves. Why not you assign yourself as a team and split up the work?
Sure, ma'am. I'll lead the project and work on the interface. My plan is to build an GUI where users can click and drag control points to reshape the Bezier curves in real time.
I love the math part. I'll explain how the curve is built, from control points to interpolation, and how we go from straight lines to a curve using Decastle's algorithms.
I write the program. I use Python and MATLAB, and first maybe switch move to interactive. Look like a program period. Make sure we can draw both the quadratic and cubic curves.
If we create an animation in a Blender and exchange make object and maybe a ball or drone, follow the Bezier curve to show how it works in the 3D motions.
I gather research, including historical context, real-world application, and use system model software like SVGs, fonts, and mobile UIs. I also help write the final report and make the presentation stable.
When three control points, draw quadratic curve. I even added the dots for the control points and a curve.
Let me add a visual breakdown. I draw a linear interpolations between the points step by step so people can see how the curve is formed. This will help explain the algorithm visually.
I have built the GUI with Kinter. You can click and drag the control points and curve updates instantly. It's basic now, but it works.
I set up the curve path in the Blender and animated the ball following. It's a smooth and very showing how the motions and guide by a Bezier curve.
I found something interesting facts, like how scalable vector graphics on websites use Bezier curves, and how they are part of every font and logo we see online. I include examples in the report.
So I did a small program. When we had more control points, the program slows down a bit. Too many recalculation.
That makes sense. More control points means more processing. Let's optimize by storing calculated values and only updating when control points actually move.
I noticed that GUI lags if the user moves the points too quickly. I'll tweak it so the curves only update after the mouse is released or after a short delay.
In the Blender, the motions look a bit tough with just 3 points. I will add a few and more and adjusting the etching and make it look more natural.
I'm updating the report to include these challenges and show that we didn't just make something, we solve problems as a team.
So, okay, what about the project finally?
In our project, the users can track points and watch the curves update in real time. It's interactive and simple to use.
So we use Decastle's algorithms to build the curve. So it starts by drawing straight lines between the control points. Then we create new lines between those lines. This continues until we get the final curve. It's like step-by-step blending.
We can use Python plot curves with MATLAB. The tool supports both quadratic and cubic curves.
We can create a path using a Bezier curves and ball followers with the path smoothly fixed out. The animations of software simulates the natural motions.
Research show that Bezier curves are everywhere, used in car design, graphics software, web design, and mobile apps. The curves are elegant and efficient, which is why they've been used around for 50 years.
So good work team, you have done your best for the project. You have converted a tedious topic into a simple topic for a beginner to understand, and it is visually good. So you have shown your creativity, collaboration, everything. Well done.
Thank you.
Thank you.